Hello, and welcome to the tutorial series for TIBCO Data Virtualization, or TDV. In this tutorial, we show how to create virtual views. Note that tutorials are not meant to be comprehensive training modules. Instead, they demonstrate a very basic use case that can be built quickly and easily. However, the Community Edition knowledge base contains additional information that will help you learn more and go deeper. Additional resources in the knowledge base include resources used to build the tutorial, such as data virtualization archive files, data source files, and a document version of this tutorial. Additional information, including documentation and training materials. Here is our agenda. We begin by defining virtual views and outlining their importance in data virtualization projects. Next, we demonstrate the basics of creating virtual views. Finally, we summarize the contents of this tutorial. Let's begin by discussing what virtual views are and why they are important for data virtualization. In TIBCO Data Virtualization, views are virtual data tables. Views are defined by SQL statements that use TDV metadata. They consist of a SQL select statement, along with any ANSI standard SQL you use to define and shape the data. In data virtualization, views often federate data from multiple disparate physical sources. Virtual views are the very heart of data virtualization. By federating data from disparate physical sources, views enable data developers to encapsulate the business meaning of data into simple relational structures, making it easier for data consumers to find and use the enterprise data they need. Views shield data consumers from the underlying complexity of the many physical data sources present in the modern enterprise. Views also enable reuse of information structures across many projects. Next, let's walk through the basic steps of creating a virtual view. Here is the business problem we illustrate in this tutorial. TDV developers want to build a virtual view that combines data from two different physical databases, and then present this data as a single virtual table for their data analysts. View building capabilities in TDV are extremely broad and deep. In this brief tutorial, we can only scratch the surface of this functionality. However, this tutorial will provide a foundation that will help you learn independently. We have already created data source connections to these physical databases, so in this tutorial, we can concentrate on building the view. If you want to learn how to create relational data source connections, please see the tutorial on that topic. Also note that there are other tutorials you will want to see after this one. First, note that this tutorial provides an introduction to view building but does not cover best practices for development. Our best practice of layered development is the subject of another tutorial. In addition, there are other tutorials that explain how to publish virtual views to make them available to data consumers, both as virtual databases and as web services. We're now ready to begin. First, create a folder for your work. You can right-click Shared or any folder of your choice. Select New Folder, give the folder a name, and click OK. Right-click your new folder and select New View. Give the view a name and click OK. A blue canvas appears in the editor area. Note the error icons in the folder structure. As the flyover text explains, this new view has no definition yet. Let's provide that definition. Open the Examples folder. Drag the Products table from the DS Inventory data source onto the canvas. Now drag the Order Details table from the DS Orders data source onto the canvas. We want to join these two tables to create our view. Drag a line between the columns to use for the join. In this case, they are both named Product ID. So far, we've been working on the Model tab in the editor. Now click on the SQL tab. Note that the work we have done on the Model tab has been automatically rendered as SQL. Now return to the Model tab. Right-click on the canvas to see some of the options available. Navigator opens a widget that will help you navigate the model if it becomes larger than available space on the screen. The other options affect the SQL for the view. For example, click Select Distinct. Then go to the SQL tab to see that the distinct keyword has been added to the SQL statement. To see more options, right-click the blue circles on the Join line. Select Properties. The Properties dialog box lets you specify many characteristics of the join, such as equijoin or non-equijoin, left, right, or full outer joins, and a number of query optimization settings. Now move to the Grid tab. This tab lets us work with the columns in the view. Select Star is the default projection. If you want to select individual columns for the projection, click any row of column for a drop-down list of available columns. If you want all or most of the columns, click the List Columns icon. Now you can select individual tables or all tables. Select all tables and click OK. Now all columns from both tables appear on the grid. Aliases are automatically generated for duplicate column names. You can also enter your own aliases for any column. If there are columns you don't want, simply uncheck them. As the SQL tab shows, our new projection has been generated. Save your work. Now execute the query. The query runs, and a small sample of results is returned to Studio. The Grid tab lets us specify many sophisticated SQL capabilities. Let's look at just a few of them. Right-click the Product Description column and hover over Function. As you can see, a large number of SQL functions are available, divided into several different categories. Let's trim any white space from the right of the Product Description column. Hover over Character and select rtrim. The editor lets us work with function parameters. In the case of rtrim, we don't need to add anything. Click OK. The function is added to the projection, and of course to the generated SQL as well. Next, we'll use the Grid tab to specify filtering and sorting. In the Order ID row, click Criteria and enter greater than 10. This will generate a SQL where clause that ignores rows where the value is 10 or less. Now add sort criteria. Click the Sort Order cell for the Order ID column and select 1. 1 is the only choice because this is the first sort we are specifying. Click Sort Type for Order ID and select Ascending. Now click Sort Order for the Product ID column. Now the drop-down shows 1 and 2. Select 2. We'll sort Product ID in descending order. As expected, the SQL tab now shows a where clause and an order by clause. Save your work. Execute the query. We see that order IDs less than 10 are filtered out, and our sort order is working as expected. Finally, let's look at editing directly on the SQL tab. I want to translate the product name column to uppercase. When I begin typing, this warning message appears. As the message notes, the Model and Grid tabs will be removed if I edit the SQL tab directly. Don't worry though, we can easily recreate these tabs. Note that there are a few edge cases in SQL that do prevent us from regenerating the Model and Grid tabs. For example, if you use SQL Common Table Expressions, TDV cannot regenerate the model and grid. Again, don't worry if this occurs. Views will still work whether or not these tabs are present. I enter my SQL and save my work. Execute the query and the product names appear in uppercase. As expected, the Model and Grid tabs are now gone. Click Generate Model on the toolbar. The Model and Grid tabs are recreated. We have examined a number of techniques for creating virtual views, concentrating on the Model, Grid, and SQL tabs. Our demo is complete. Let's summarize what we have seen in this tutorial. In TIBCO Data Virtualization, views are virtual data tables. Views are defined by SQL statements that use TDV metadata. They consist of a SQL select statement, along with any ANSI standard SQL you use to define and shape the data. In data virtualization, views often federate data from multiple disparate physical sources. Virtual views are the very heart of data virtualization. By federating data from disparate physical sources, views enable data developers to encapsulate the business meaning of data into simple relational structures, making it easier for data consumers to find and use the enterprise data they need. Views shield data consumers from the underlying complexity of the many physical data sources present in the modern enterprise. Views also enable reuse of information structures across many projects. As you work with virtual views, keep these key takeaways in mind. Views are created graphically on the Model and Grid tabs of the View Editor. You can also create views manually on the SQL tab. If you choose this approach, the graphical tabs will be removed. However, they can easily be recreated in most cases. In edge cases where the graphical tabs cannot be recreated, the views will still work correctly. The graphical tabs are not required. As a data developer, feel free to move between graphical and manual modes freely and work in whatever way is most convenient for you at any given moment. After completing this tutorial, you are ready to begin creating views against all your physical data sources. You are also ready to explore other features of the View Editor that we did not show in this tutorial. To learn more, see our tutorial on layered development best practices, as well as tutorials on publishing views for end-user consumption. Thank you.